Okay, so here we are. We're talking about the remote Keurig project, and this is the web interface here, where you have the capability to control the remote Keurig. So we have the capability to turn the power on, select a 6, 8, or 10 ounce cup, and then to brew the coffee. So where I'm going to go to now is the code that is on the Arduino, and what this does is, first off, it imports libraries such as the bridge library, which allows the two processors on the YUN to talk to each other, the server capabilities and the client capabilities. Again, that's passing between those two things on the YUN. Initialize a server object, assign descriptive variables to the pins. These are inputs and outputs on the YUN, and assign a default value to the brew size. This is all happening ahead of running the setup function, which begins the communication between the Linux board and the YUN, which is the serial begin and bridge begin. Then we're going to assign a pin mode function, which tells it what to do with those named pins. It's setting them as output because we're going to be using that to send power to relays. And it also instructs it to listen for any incoming connections on the server. So coffee server begin. The code that runs continuously is to get any clients coming from the server, and if there is a new client, read the command. Now this is where the web page comes in, and it's reading a string called command using the read string function, and then command trim. Now what that command trim function does is it instructs it to ignore anything past a certain point. So in this case, when we click turn on, it goes to this web address Arduino power. Now that trim method is going to ignore everything from back here and just assign power to the string command. And what's going to happen there is it's going to look at that string command and say, is it power? If it is, then it's going to set the brew size to default and call the turn on function. Then it's going to tell us what it's doing, which you saw in that example. It's going to print out to the browser that you turned on the brewer and that you need to use the back button to return to the main. So it's going to go through these series of else if statements, asking, what command is it getting? So, and then it'll call the function for 10 ounce, 8 ounce, 6 ounce, etc. So, I think it's possible I could have refined this further by just making the size function accept the string as an argument and then working it similarly. But again, here I was kind of between fighting with the thing, trying to take it apart and put it back together again. I went with the simplest method, and this could certainly be refined further. All of the functions, turn on, menu button, left button, etc., they all work by applying power to a relay, which then shorts the contacts on the button on the back of the board, which I soldered the wires to. So what it does is it sets the initial state to low, and then it sets it to high, uses the digital write function to tell it which pin and what state to assign, waits 250 milliseconds, then does the same thing while turning it off. Now the one function that turned out to be pretty essential was clamshell, which effectively simulates opening and closing the K-cup holder on the brewer, because if you don't do that, it won't allow you to select the brew size, and after a few seconds it goes back to its default state, which says, oh, you didn't put a K-cup in, so we need to wait. So when we go to select the brew size, say a 6 ounce, again here it parses that 6 ounce from the line there to tell it to command it. And then, so now that we've selected that size, we can hit brew coffee. Now, if we don't select any size, it's going to default to an 8 ounce. But brewing the coffee, click that. You can hear it in the background cycling the relay. And making the coffee. So there you have it, the remote Keurig. It's pretty basic in functionality. Certainly with more time we could have added a lot more to it, but it works, and that's about the best we can ask for.